Alright, hello everybody, welcome to the first in a series of videos where we're going to be going over the design process for robots for the different seasons of robotics. We're going to be using previous seasons as a way to kind of get a gauge for how we actually want to go about doing design for future years and stuff like that. So, the first example we're going to use is today we're going to be looking at Rapid React. This was my first non-online game that I did, and so it's got a special place in my heart because it was the first game where I ended up getting to go to Worlds and the first game where I really got to make my own robot. So it was quite fun. But now what we're going to do is we're going to be approaching it from a different perspective. I'm going into this, I haven't done any prep. The robot I designed here is probably going to look very different from what I would have designed it back then. And we're just going to kind of see how this goes. So I've got the manual up here on the side as I need it, and I'll refer back to that regularly throughout the time. But we'll start by creating our new document. We're just going to name this example 2022. Great. So now I've got our document. If we go back out in the Onshape, we go here, we can see we have example 22. Click in on here, we have our first document. And what we're going to do from here is we'll see we're given two things immediately. We're given an assembly, we're given a part studio. First thing I'm going to do is I'm going to rename our assembly to, we're going to rename this to main. Eventually, this is going to become the main assembly where all of our stuff is included. We're going to be using some add-ons such as MKCAD, which we use because it's got access to a bunch of different parts and stuff. You'll see it's going to be changing and updating fairly soon to the new season, but that won't impact us because we'll still have access to all the things we need. And now on the other side, we'll see that we also have a parts studio. This is where we're going to be doing the first step in all of our work. So when you're doing design for a robot, there's a lot more than just going about trying to figure out the three-dimensional parts of it. You first, before you do anything, no matter where you're at, you always want to start with some sort of a sketch. So what we're going to be doing is we're going to be starting with a 2D sketch of what we want our robot to be. And from there, we're going to kind of progress on to making it so that it's more finalized. So what I'm going to do here is I'm going to put a list of our requirements that I'm going to put down for myself. And we'll refer to these throughout the time. I just want to get them put down so I have something to kind of go off of a little bit more specifically. So one of the things I want to do is I want to do an over bumper intake. I want to be able to shoot cargo, which will make more sense later when I explain what the game element is for this game. And I want to be able to do some sort of a climb from this season, which is quite complex. So it'll be interesting to see how it goes on this side. So we'll see. These are kind of the three overall goals I'm going to have for while I'm designing this. So the things I have as takeaways from this are that I'm going to need an intake. I'm going to need some sort of an index on the inside of the robot. I'm going to need some sort of a shooter. I'm going to need some sort of a climber. So I'm seeing 4 subsystems I'm going to need, and we're going to start kind of including all this together. One of the limits I'm going to set on myself for this are that my frame size has to be, we'll go with 26 by 26. Just deciding this now. So we'll see how that goes. But this is going to be what we're going to be working in. So I'm kind of doing this so that I can kind of have my plan set ahead of time a little bit more. So it's a little bit easier for me to have everything ready to kind of convert over so I have less decisions I have to make in the long term. In reality, for an actual competition, you're going to specifically choose these choices. And there's going to be more thought going into it. But for this example, we're just going to choose some arbitrary values that we're going to be following. So we're going to be doing that. We're going to be using swerve. If there ever comes a time in the future where we're not using swerve, I will be a little surprised. Swerve is just very robust, and there are a lot of ways you can make it work. And on top of being 26 by 26 and swerve, I'm going to be a little bit more specific, and I'm going to say that we're going to be using... that did not work as well as I wanted. There we go. And I'm just going to say we're using West Coast Products 2XI or something. Oh, hold on. Let me see what they are. I believe they're in here. Swerve. Okay. I just wanted to double check. They are in fact called X2s, so they're not listed here, but they will show up when we're actually over in our assembly. One thing you'll notice is when we're in a part studio, some of the things that we have access to are going to be a little different from. If we now go over into main and we reopen this, you'll see there's a couple more options, and if I open Swerve, you can see there's a lot more options. So we'll be using this specifically for when we're in our assembly, so it doesn't matter for right now. What I'm going to do is, before anything else, I'm going to rename this to our 2D sketch. So, I'm going to look at it from the right plane. So, long term, my goal is I want to make everything kind of be a straight line. I want to be able to have everything kind of go all the way through the robot in a 2D motion, which should be pretty achievable. We'll see as we go on how that changes and how my approach might change a bit, but we're going to start with this for the meantime. So, first thing I'm going to start off with is I'm going to open my sketch. We're going to start with our frame, which we know is made of 2x1 per usual. So, first thing I'm going to do is I'm going to set the height to 2 inches. Whoa. And then, if I remember correctly, we said that I will be doing 26 by 26 for our frame. So that means that for our width, I'm going to put that as 26. Awesome. We're going to click check mark. There we go. Look at that. There's our frame. How wonderful. On top of this, what I'm going to do is now on the right plane, I'm going to make another sketch separate from this one I already had. And now I'm going to add on some bumpers. Now, to add on bumpers, I am going to reference back to our manual. And I want to see what the rules are on it because they change from year to year. And I'm going to follow the rules for this year. Note that for every year after this, there are slightly different guidelines. So you'll need to keep that into account for while you're doing this. But what I am looking at is trying to see how the rules work for this year. So I'm saying they're talking a bit about corners. How corners work. See if I can find what I need. I haven't looked at this in a while. But we'll see. Okay. So, bumpers must be constructed as follows. Whoa! That was unneeded. Oh, that messed me up. There we go. Backed by 3/4 inch thick by 5-inch tall plywood. Okay. So, we know that our bumpers are going to be 5 inches tall. So I'm going to draw that in. We're just going to say it's going to be exactly 5. It might change a bit, but for now we're just going to go under the presumption that we're at 5. This is, again, something you'd probably figure out in the midst of while you're doing all this design and stuff. But for our case, we're just going to kind of predetermine it. Now, let's see. I see I've got 3/4 inch thick backing. I believe if we now scroll further down, we can see we normally use 2.5 inch pool noodles. So 2.5 inch plus our 3/4 is going to get us to a total of what I believe will be 3 1/4. Yes. So now what I'm going to do is make our box. Now what I can do is I can make the bottom, I believe you said 3.25. So I'm going to do that. There we go. So now we've got the box for our bumpers, but right now we can still move it around a bit. Something I'm realizing now that might be nice to have is it might be nice to have how deep our wheels are. So what I'm going to do is I'm going to come over here into main. Come over to my MKCAD setup. Go look for swerve. I'm going to look for the model I need, which I need the X2s. Here you can configure all your options. What I know is that I need X2I, which are the inverted ones, because that's what we have on hand as of this year that we're using. I'm going to do corner mounting. We'll use Krakens, drive ratio, steel, gear material, steel. That's fine. I believe we use 12 tooth, so I'll switch it to that. And this, we're going to be using the tread model. And I believe we'll probably be using corner with bottom support plate. Taking a minute, but it should hopefully get in here eventually. There we go. So, now we have our model of our swerve. And the handy thing about having this all on hand here is that I don't have to go and find any measurements real world. I can use all these because I know these assemblies are based off the same setup that we have. So, the inner gear ratio might be a little different, just because I don't know exactly what we have. I'm pretty sure we have 12 tooth, but I could be wrong. But aside from that, we're still able to get all the measurements we need. So, we know just by the looks of this, you can kind of tell that our 2x1 frame is going to kind of go in here where these bolts are. These bolts will go all the way through the 2x1, kind of working to clamp it in. So I'm going to see. So if I measure top to bottom, they have 2 inches. So let's measure from the top down to the bottom. See how this works out. Down here, you have a handy little measuring tool. We're going to click on this. We're going to have a little menu pop up with a lot of values. The nice thing about all these values is that they're all pretty easy to figure out what they are in reference to. So you can see min distance here. This just shows the minimum distance between the two faces. We have the center axis distance, which is 1.75. That might be pretty handy. So we can see this 1.75 from the center. On the other hand, this one doesn't look too handy. What I'm trying to do is I'm trying to find from this top line up here down to the bottom. So what I can do is, since it gives me the center of the circle, I can find the diameter of this, which we're going to find is going to be 4 inches. If I measure these two, we'll see center axis distance is 1.75. So what we can do is we can do 1.75. That goes to the center. If we add on another radius, which is 2, we're going to get 3.75. So now that I know that, I can take this back over to my 2D sketch. And we're going to leave that sketch alone, actually. But what we are going to do is we're going to go back into editing this one. We're going to add some circles, preemptive here. Put them there, just preemptively for now. I said these are going to be 4. I'm going to put them in. And basically what we know is from the bottom of these to the top of this, our value is going to be, I believe we said 3.75. So there we go. And we know we'll be somewhere in here on the frame. Let's look. Let's just double check. It looks like, if I'm looking to the right of it, it looks like it's going to be pretty much right up into the corner. So, well, here, let's see. What's the distance here? 0.2 inches. All right, cool. We can do that. Over in our 2D sketch, we'll do right here. I'm going to do right here. I'm going to do a distance of 0.2 inches. There we go. What I'm actually going to do instead is I'm going to delete that. Redimension this bad boy. So here. Also going to notice on top, we have a height of, let's see, for the top, we're going to end up being, I'll go off the top of this guy right here, about 2.75 inches. And that 2.75 inches tall. And we've got, oh, that ain't very helpful. 7.2 inches, roughly. Yeah, 7.2 inches unavailable by going to the right. So we have 7.2 inches for the top block. So what I'll also show here is we're also going to be adding in the swerve top. This is also going to be a thing that's going to kind of be a limiting factor. So we're going to set this to be, I believe it said 7.15, but we're going to say 7.2-ish. And then if we go back, check up here again, just double check all my measurements. We will get 2.75 roughly. Good enough for me. There we go. Well, these two things are going to be blocked off on both sides, and they're going to be equal and exactly opposite of each other. So what I'm going to do is I'm going to take all of these, and I'm going to click up here. You'll see there's a mirror function right here where my cursor is. Click on that. I have all these selected. It's going to say select a mirror plane. I'm going to select this. Bada boom. There we go. Now this is handy, because now what I have here is I have a more finished scale of what the robot's going to need to look like once we're kind of done. And this is going to be a better example of showing what areas are kind of off limits. So now we have that. I can go back into editing this sketch. And generally, as teams get further and further on, and they start to use over the bumper intakes more and more, they're going to find that a lot of the time when you have a very flat field that you're playing on, you're going to want your bumpers closer to the ground, so there's less of a chance of things getting picked up underneath it. Good examples could be game pieces, especially if you have thinner ones that you might really not want to get under your robot. Other examples I can think of are if there are other random elements on the field you want to avoid. And also just so that it helps give a little bit more stability by lowering the center of gravity in your robot by a bit, by lowering how far down the bumpers are. So I'm just going to preemptively set this to, we'll say 0.5 inches. 0.5 inches should be a generous amount. It's about your finger. At least about my finger. Can't speak for anybody else. So now what I'm going to do, I'm going to do the same thing I did for these boxes. Click over here. And grab these, same mirror function over this line. There we go. Got those now. And now, whoa. That was weird. And now we're here, back here. What I'm going to do is I'm also going to add in some fillets, because what we'll see here is when we look at our example over here, we can see that we don't have just a straight line. What we actually have is a circle here that we're going to have to account for. So we can see that our diameter is 2.5 inches. And that'll be handy here, because when I add in my fillet, it's going to ask me for what size. Now that over here gave me 2.5 inches. That's our diameter. Our radius is going to be half our diameter, which means that our radius is going to be 1.125. So we set this to be 1.125. There we go. I'm going to do that on all of these corners because we'll need that. There we go. Now we have all of those done, which will be nice. I'm going to get these measurements into a slightly better spot. There we go. So now we've got our robot frame done, and we also have our bumpers done. So now we have all that. Now we can start to get into some of the more fun stuff where we actually start to look at adding in game pieces and starting to come up with how we actually want to lay out the inside of our robot.